aldehydes and ketones. Okay, so that's what we were discussing with respect to aldehydes and ketones. 1 minute. Okay. Now can some of you tell me, or any one of you, what we were discussing in the last class? Any one of you? First, what we were discussing? Okay, so good morning. Okay, good morning. So what we were discussing in the last class, I want the points. Okay, Itard reaction. Yes, Archit. We were discussing about the Itard reaction. So what do you mean by Itard reaction? What do you mean by Itard reaction? What is Itard reaction? So Itard reaction is nothing but Itard reaction. Now it is nothing but conversion of toluene to benzaldehyde. Conversion of toluene to benzaldehyde. Now, what else is required here? We require chromyl chloride. Yes, we require chromyl chloride. That's what. This reagent is very important. Chromyl chloride. So that's where we have the Itard reaction. This is with respect to Itard reaction. What is the drawback of Itard reaction? Any one of you? Conversion of toluene to benzaldehyde in the presence of chromyl chloride. Absolutely correct. Any disadvantage with respect to Itard reaction? Can any one of you? Any disadvantage with respect to Itard reaction? We can't take anything except toluene. Yes, very good. So with respect to Itard reaction, only toluene can be used. Only toluene can be used, or as the people have mentioned, only benzaldehyde can be produced. Only benzaldehyde can be produced. So either only toluene can be used, that means only benzaldehyde can be produced. What will happen if I take any other reactants? What will happen? For example, I will take ethyl benzene. So what will happen to ethyl benzene? Whether we are not going to get aldehydes as the product? If I take ethyl benzene, definitely we are going to get the aldehyde as one of the product. That will not be the only product. It will be one of the product. There will be formation of ketones also. There will be formation of, yes, Sanjana. So there will be formation of ketones along with the aldehydes. So once again, another step I should follow. That is purification. So where I have to purify the aldehydes, because we are interested in aldehydes. So that's where we have the drawbacks with respect to Itard reaction. That is one thing. So what else we had discussed in the last class? Since Archit told Itard reaction, I started with Itard reaction. What else we had discussed in the last class? Itard reaction, yes, fine. But we have discussed about other things also, right? What is that? Yes, very good. So we have discussed about Dibal H. We have discussed about Dibal H. So what is Dibal? Dibal is nothing but diisobutyl, right? So diisobutyl aluminium hydride. Aluminium hydride. So that's when we have the Dibal. So what is Dibal? Which type of reactant or chemical it is? What is the role of Dibal in a reaction in organic chemistry? Can any one of you? Archit, whatever you had written, it is correct. We have discussed about chromic oxide also. I will come to that. Okay. So Dibal H, it will act as a reducing agent. Yes, very good. It will act as a reducing agent. So in this case, which particular reactant will get reduced? Yes, Archit, I will come to that. Whatever you have written, it is correct. Even yesterday we have discussed about chromic oxide. Yes. Now, which particular reactant will be getting reduced in this case? Yes, nitriles and esters. Very good. So that's where we have the nitriles, which will get converted into aldehyde by the hydrolysis in the presence of Dibal H. In the presence of Dibal H. Same way as the people have written, even esters will be reduced. Even esters will be reduced in the presence of Dibal H to aldehydes. What will be the another product with respect to esters? What will be the another product with respect to esters? Anyone? What will be another product? So here, what is that another product when it comes to nitriles? Simply I am asking, in exam, board exam and all, it's not required, another product and all. Okay? But here I am asking. So what about first one, which is the another product here? In second case, aldehydes and alcohol. Yes, very good. So that's where ammonia will be produced. Even this one we have discussed in the last class. Very good. So that is the application of the Dibal H, which will act as a reducing agent. Fine. Now we will move to next one. What else we have discussed? As Archit has written, that is with respect to chromic oxide. By using chromic oxide, where toluene will be there. Okay. So in the presence of chromic oxide or chromium trioxide, anything is fine. Chromium trioxide. And the reactant is acetic anhydride. Reactant is acetic anhydride. So why they are called as anhydride? Any one of you? Why acetic anhydride? Why anhydride in the name? What is the reason? So toluene with acetic anhydride in the presence of chromic oxide. So what will happen? Definitely there will be formation of benzaldehyde. There will be formation of benzaldehyde through the intermediate benzylidene diacetate. Through the intermediate benzylidene diacetate, it will get converted into benzaldehyde. Yes, water is removed from 2 acetic acid, so therefore it is called as anhydride. Okay, so anhydrous or anhydride, that means absence of the water. Okay, very good. So in that way we have got the preparation. Anything else I have missed out in this reaction? Anything else I have missed in this reaction? Any one of you? Anything I have missed in this reaction? Anything? Yes, temperature, very important. Temperature, it is nearly 280 Kelvin. So it will be nearly 280 Kelvin. Or we can mention this one as around nearly 5 degrees Celsius or 0 degree. 0 to 5 degrees Celsius. So that's where we have the important point. Temperature we have to mention. If they have specified the temperature means in that particular temperature or near to that temperature reaction has to be carried out. So that's where we have to mention the temperature. So that's where a toluene can be converted into benzaldehyde by 2 reactions, what we have discussed. One is by the Ithard reaction and another one is that is by chromyl chloride method and another one is by using chromic oxide or chromium trioxide. Okay. Now, these are not only 2 steps or 2 reactions. We have another reaction that is by halogenation. That is by halogenation. We have another method where a toluene can be converted into respective or toluene can be converted into benzaldehyde. Not required, respective is not required. So toluene can be converted into benzaldehyde by the halogenation. So what do you mean by halogenation? Many times, even in first PU people have studied. So what do you mean by halogenation? And please remember, I will make a point. So this is the commercial preparation, very important. Commercial preparation of benzaldehyde. This is the commercial preparation of benzaldehyde. What do you mean by commercial preparation? Large scale preparation. That means investment will be less. Yes, Archit, adding of halogens. Whatever Arpit has told, it is absolutely correct. Halogenation means adding of the halogens. Okay? So we have the toluene. That means there will be presence of a methyl group. Now, halogenation of this molecule can be carried out by, if it is wrong, that is fine. Halogenation of this particular molecule can be carried out by, we have a hydrocarbon, alkyl group in its side chain. So halogenation can be carried out in first PU. I am giving a hint. In first PU, you people have studied that particular process, that is halogenation. Okay, chlorine. So if I add chlorine directly, I can have the halogenation, or it can be promoted by something else. Anyone? Yes, in the presence of sunlight. Very good. So halogenation in the presence of sunlight. H nu means energy. Okay, light energy. In the presence of sunlight, halogenation can be done. Hagadre, when I am talking about halogenation, so that's where we have the intermediate. That's where we have the intermediate CH, Cl2. CH, Cl2. Now, other intermediates will be there. This is one of the intermediates, CH, Cl2. Name of this intermediate will be benzyl. Name of this intermediate will be not benzyl. Name of this intermediate will be benzyl chloride. Okay, benzyl chloride. Because only CH is there. Benzyl chloride. Okay, so even benzyl chloride will be produced as an intermediate. We have written this one as an intermediate, that is benzyl chloride. Okay, now later on acid hydrolysis, on acid hydrolysis, on acid hydrolysis. So what do you mean by acid hydrolysis? You can simply mention acid hydrolysis means H3O plus. We can simply mention this one as H3O plus. So on acid hydrolysis, it will get converted into respective aldehyde. It will get converted into respective aldehyde, CHO. Other products will be HCl. Anyway, it will be dissociated because we are going with acidic condition. So not required. HCl will be released naturally, but those HCl, it will be in dissociated form due to the acidic condition. Already it is in acidic solution. So therefore benzaldehyde will be product. Only thing is we have to heat the solution. Heat it nearly up to 373 Kelvin. Heat it nearly up to 373 Kelvin. For the first step, heating is not required. But for the second step, there will be heating. Heating of the solution. So this is where we have the commercial preparation of benzaldehyde. So don't think that for commercial preparation, we are going with Itard reaction or Itard reaction, or we are going with Rosenmund reduction reaction. Okay, so they are not the commercial preparation. When it comes to the commercial preparation, that is by the halogenation, or to be more appropriate, side chain and halogenation, because substituent is getting halogenated or chlorinated in this case. Got my point? So this is where we have the commercial preparation of benzaldehyde. Any doubts with regard to this one? So if you observe it carefully, in this case less reactant, because one of the condition is natural resource, that is sunlight. So therefore this is a simple method. Investment will be less, but whatever benzaldehyde will be formed, it will be of high efficiency. That means product formation will be there with less investment. And we are getting pure benzaldehyde. No purification is required. No other products. Okay? So try to remember those intermediates. Now when it comes to earlier one, it was benzylidene. It was benzylidene diacetate when we are talking about chromic oxide, but here it is benzyl chloride. Try to remember this intermediate, whichever is mentioned in your textbook, otherwise not required. Okay, so that's where we have the commercial preparation of benzaldehyde. Now whatever I will be telling next, it will be very, very important. It will be very, very important. So that is nothing but Gutterman-Koch reaction. That is nothing but Gutterman Koch reaction. Very important with respect to your examination point of view. So Gutterman Koch reaction. Hagadre, in the name itself it is there. It is based on the person name who standardized or discovered or who made this particular protocol for the reaction. So that's where we have the Gutterman Koch reaction. So this is where we have the preparation from benzene. Preparation of benzaldehyde from the benzene. That's where we have the Gutterman Koch reaction. So what is Gutterman Koch reaction? It is the preparation of benzaldehyde using benzene. No toluene. It is benzene. Okay. So that's where we have the benzene. That's where we have the benzene. Okay. Now it will be converted into benzaldehyde. It will be converted into benzaldehyde, CHO. So that's where it will be converted into benzaldehyde. Hagadre, what is that difference between these two? All of us we know that when it comes to benzaldehyde, one extra carbon is there. In the form of aldehyde carbon, one extra carbon is there. Right? So that's where we have the benzene and benzaldehyde. That's where the difference. Okay? So hagadre, from where that extra carbon came? That extra carbon came from carbon monoxide. That extra carbon came from the carbon monoxide. Okay? Now, carbon monoxide in the presence of HCl and aluminium trichloride or cuprous chloride. Aluminium trichloride or cuprous chloride. So aluminium trichloride plus 3. So cuprous chloride, that is nothing but Cu plus. So that's where we have the cuprous chloride. Any one of these two can be used, not cupric. Some students they will write cupric chloride. Okay, not cupric chloride, it is cuprous chloride. So carbon monoxide in the presence of HCl, benzene will be converted into respective, that means benzaldehyde. That's where we have the Gutterman Koch reaction. Hagadre, what is the role of aluminium trichloride or cuprous chloride? Any one of you? What is the role of aluminium chloride or cuprous chloride? Because these catalysts we have discussed already. Sandmeyer's reaction, Friedel-Crafts reaction. Yes, very good. So they will be acting as a Lewis acids. They will be acting as a Lewis acids. So even cuprous chloride is a Lewis acid, no doubt. So some students they will get confused. How come, sir? Cuprous, lesser oxidation state where copper is +1. But if I am talking about cupric chloride where copper is +2, higher oxidation state. So cupric chloride should be the Lewis acid. How come cuprous chloride? Right? Because any compound where highest oxidation state, they will be acting as a Lewis acids. In case of aluminium, highest oxidation state is +3. So therefore, aluminium trichloride, it will act as a Lewis acid. Same logic is applicable here also. In case of cupric chloride, they should act as a Lewis acid. How come cuprous? But if you see the electronic configuration, cuprous form of copper is the stable one, not the cupric form. Cuprous form of copper is the stable one, not the cupric form. Okay? So that's where we have the cuprous chloride which can act as a Lewis acid. Cu plus, that's where copper will be stable. Cu plus 2, copper will be bit unstable based on the electronic configuration I am talking about. Okay, so that's where we have the Lewis acid as a catalyst in this reaction. HCl and these metal halides, they will be acting as a catalyst. Reactant will be carbon monoxide and the benzene ring. Carbon monoxide and the benzene ring. And to some extent, HCl is going to provide acidic condition also, and at the same time it will be involved in the reaction, but at the end it will be regenerated. So therefore I told HCl and aluminum trichloride, they will act as a catalyst. Carbon monoxide is a reactant. So that's where we have the Gutterman-Koch reaction. Any doubts? Any doubts with regard to this one? Same way, I can use not only benzene, any other compound I can use with Gutterman-Koch reaction, but this is the common one where benzene is getting converted into benzaldehyde. Okay, so if I am using toluene, okay, fine, yes. If I am using the toluene for Gutterman-Koch reaction, what will happen? What is your expectation? If I am using the toluene and I am going for Gutterman-Koch reaction, what you expect? Any one of you? Methyl benzaldehyde. Oh, beautiful answer, Archit. Very good. So that's where methyl group will not be disturbed. It will remain there. But benzaldehyde group will be added because we are going with extra carbon. So that's what it will happen if I take toluene. If I take toluene. No Sanjana, no 2-phenylethanol, no. It will be added over here. That means 4-methyl benzaldehyde or benzene carbaldehyde. The product will be 4-methyl benzaldehyde or benzene carbaldehyde. Okay, so that's where we have the reaction. This will be the major product because they are far from each other. So that will be the major product, that is 4-methyl benzene carbaldehyde. So what I need to tell you is Gutterman-Koch reaction, normally it will be used for conversion of benzene to benzaldehyde, but that doesn't mean that it will work only with respect to benzene. No. Any other hydrocarbon derived benzene can be used. Okay, so now only thing here is CHO will be added to another place other than the where alkyl group is attached to the chiral, and they will be far from each other. That's where major product concept comes. Okay, so that's where we have the reaction. This is nothing but Gutterman-Koch reaction. Now, same way, we have another reaction. Don't get confused. This is not there in your textbook. To make help for your competitive exam, I am telling, we have a reaction called as Gutterman reaction. We have a reaction called as Gutterman reaction. In this case, all the conditions will be same. That means what I mean to tell you is, anyway, for board exam they will not ask, no doubt. So they will take the benzene, okay, they will take the benzene. Now this benzene with hydrogen cyanide, and HCl, with hydrogen cyanide and HCl, okay. So they will get converted into aldehydes. ಹಾಗಾದರೆ which is the source of carbon here in Gutterman reaction? Which is the source of carbon? In a Gutterman coach, it was carbon monoxide. But here, which is the source of carbon? All the other conditions will be same. Yes, it will be nitrile carbon. That means this one. Nitrile carbon will be the one which will be source of the carbon. That is HCl, hydrogen cyanide. So another product can be ammonium chloride. Okay, since we are going with acidic condition. Okay. Anyway, this is not there in your textbook. For your information, I have given. That's where we have the Gutterman reaction. Where benzene with hydrogen cyanide, it will get converted into benzaldehyde in the presence of Lewis acid as a catalyst. Okay. So this is where the reaction. But still, when it comes to the preparation, we prefer Gutterman-Koch reaction. What might be the reason? When it comes to the preparation of benzaldehyde, if I compare between Gutterman-Koch and Gutterman reaction, we prefer Gutterman-Koch reaction method. What might be the reason? What might be the reason? Sir, can we use substituted benzene for Gutterman reaction? Substituted benzene. Yeah, it can be. Okay, it can be. But now the question here is, why we are preferring Gutterman-Koch reaction? No minor product. Okay. It will be there. No doubt it will be there. Any other answer? In a reactant it is there. Answer is there. In the reactant. One of the reactant, the answer is present. High yield. Okay. Fine. Now the better answer is hydrogen cyanide is toxic. Hydrogen cyanide is very toxic. So therefore, due to the toxicity of the reactant, anyway, nowadays they are using zinc cyanide in the presence of carbon monoxide. Okay. So therefore, they are preferring Gutterman-Koch reaction. Yes, Arpit. No doubt. Even carbon monoxide is also toxic. But cyanide, hydrogen cyanide is much more toxic. That is one thing. But please remember, whatever method I have written or whatever method we have discussed, they are not commercial one. Large scale preparation it will be done, just we have discussed, that is halogenation. That will be the one which will be used for the large scale preparation. So no need to worry about the pollution and all with respect to Gutterman-Koch reaction, because that is not the commercial method for the preparation of benzaldehyde. Okay. So normally for commercial preparation, first thing, there should be less investment, and second thing, it should be environment friendly. That's what we have observed with respect to preparation of benzaldehyde. Okay. Fine. Any doubts? Okay. So hagadre we will move to next one. Now exclusively we will be talking about preparation of ketones. Preparation of ketones. So you should not get confused. First, with respect to alcohols and all, they were talking about preparation of both aldehydes and ketones. Then they focused on only on aldehydes with respect to the preparation. Now they are talking about preparation of ketones. Okay, that is with respect to preparation of ketones, exclusively ketone only. Right? The first method, it will be from preparation of ketones using acyl chloride. Preparation of ketones using acyl chloride. Right? When it comes to acyl chloride, already we have prepared aldehyde. Which is that reaction? Using acyl chloride as a reactant, we have already prepared the aldehyde. Which is that reaction? Any one of you? Which is that reaction? Yes, very good, Archit. That was Rosenmund reduction reaction, where acyl chloride were getting converted into aldehydes. Yes, both of you are correct. That is Rosenmund reduction. Here, we are not talking about Rosenmund reduction. Rosenmund reduction is meant for conversion of acyl chloride or acyl halide to respective aldehydes. But here we are talking about conversion of acyl halide, that is acyl chloride to respective ketones. So this is not a Rosenmund reduction. You will come across when I will be discussing about the reaction condition also. Okay? So the first thing here is they will use the Grignard reagent in this reaction. They will use the Grignard reagent. Now can you see the application of Grignard reagent? Already we have studied Grignard reagent in haloalkanes and haloarenes. Along with that, we have discussed about the application of Grignard reagent in preparation of organic compound, and here also another example. So what are Grignard reagents? Can any one of you send me the general formula for Grignard reagent? What do you mean by Grignard reagent? Yeah, that is alkyl magnesium halide. Very good. So that's where we have the alkyl magnesium halide. So this alkyl magnesium halide, it will be treated with cadmium chloride. It will be treated with cadmium chloride. Okay, so this is Grignard reagent. General formula I am using Grignard reagent and cadmium chloride. Now what will happen here is, now this will be having negative, this will be having positive, because cadmium is a metal, right? Same way, magnesium will be having positive, halogens will be, halides will be negative, and this alkyl group will also be negative. Okay, got my point? So that's where we have the dipolarity in the reagents. Now, positive part, that is cadmium, will go with the negative part. Will go with the negative part. And whatever negative part is there, it will go with the positive part. Whatever negative part is there, it will go with the positive part. All of you have understood? Okay? So therefore, to saturate the cadmium, we should take the two Grignard reagents. Anyway, balancing is not required, but still, formula we have to write it properly. So therefore, I am writing it 2 here, because cadmium can have the +2. Okay? So therefore, one alkyl group with one delta minus. So therefore, 2 alkyl group is required. Okay? So therefore, I am going to get R2CD, dialkyl cadmium. I am going to get the one of the product as dialkyl cadmium. Okay, dialkyl cadmium. That will be one of the product. Dialkyl cadmium will be one of the product. So what will be another product? Another product will be magnesium halide twice and chlorine. magnesium halide twice and chlorine. Okay, so that's where we have the reaction, or we can simply write it as you can simply write it as 2MgXCl. 2MgXCl. Okay, magnesium halide chloride. So that's where we have the another product. We are interested in dialkyl cadmium. We are not interested in another product. Okay. Now what is the role of Grignard reagent in this method? It is not directly involved in preparation of ketones, but it is helpful in the preparation of dialkyl cadmium, because for the next reaction dialkyl cadmium will be utilized. Say for example, this is step 1. This is step 1. So we have this step 2. So that's where we have the RCOCl. Okay, to avoid the confusion, I will make it as R prime. So this is acyl chloride. This is acyl chloride. Okay. Now it will be reacting with dialkyl cadmium. It will be reacting with dialkyl cadmium. Once again, same type of reaction. Once again, same type of reaction. Here it is negative, positive. Got my point? So here also negative, positive. Now what will happen? Positive part will go with the negative and negative part will go with the positive. That's what it will happen. So as here cadmium plus 2, so naturally it requires two molecules of acyl chloride, same as here. It requires 2 molecules of acyl chloride. Now what can be the product? Now the product will be, observe here carefully, R prime CO R. Sorry, R prime CO R. So that's where we have the 2 molecules of ketones. So 2 molecules of ketones. So what will be the another product? That is the regeneration of cadmium chloride. That is the regeneration of cadmium chloride. Got my point? That's where we have the reaction. So if I want to go with overall reaction, I can see, so cadmium chloride will get cancelled, R2CD will get cancelled. Now the reaction will be 2 molecules of R, that is Grignard reagent, plus 2 molecules of acyl chloride, which will get converted into 2 molecules of magnesium halide chloride plus 2 molecules of ketones. So that's where we have the overall reaction. Any doubts with regard to this one? Got my point? So what I mean to tell you is, in this case we have 2 steps, step 1 and step 2. So what is that step 1? In step 1, Grignard reagent will be treated with cadmium chloride to get the dialkyl cadmium. It's very simple to write the products in this reaction because we have dipolar molecules. So dipolar molecule, it is very easy to predict the product. That is because cadmium with positive, chlorine with negative. So magnesium, naturally it will be positive, halogen negative, alkyl group also negative because it is attached to magnesium. So now positive part, that is cadmium, it will go with the negative part, and negative part it will go with the positive part. So that's where we have the dialkyl cadmium. We are not worried about magnesium halide chloride. Okay. So now in the second step, whatever dialkyl cadmium is there, it's going to react with the acyl chloride. So what is that acyl chloride? Once again, dipolarity is there. So negative, positive. This carbon will be positive because it is attached to halogen, it is attached to oxygen. So that's where carbon will be positive. Now due to that, once again, positive part will go with negative, negative part will go with the positive. That's where we have the ketones and cadmium chloride will be regenerated. Cadmium chloride will be regenerated. That means in this case cadmium chloride is acting as a catalyst. It's not a reactant, it is acting as a catalyst because cadmium chloride is getting regenerated. Grignard reagent and acyl chlorides are the one which is actually the reactants. So that's where if I see the overall reaction, if I combine step 1 and step 2, that's where I can see the overall reaction where 2 molecules of Grignard reagent reacts with 2 molecules of acyl chloride to have the 2 molecules of magnesium halogen chloride and 2 molecules of ketones. Got my point? Any doubts with regard to this one? If you have any doubts, you can ask. Okay. So this is where we have the reaction with respect to preparation of ketones from acyl chloride and Grignard reagent. From acyl chloride and Grignard reagent. This is where we have the reaction. If I will go with some examples now so that it will be helpful for you. So for example, if I take ethyl magnesium chloride. So ethyl magnesium bromide, ethyl magnesium bromide, CH3, CH2, magnesium bromide. Okay, if I go with methyl magnesium bromide and if I treat with the cadmium chloride, that is one thing. And acyl chloride will be with respect to methyl or acetyl chloride. Acetyl chloride. So what will be the product? Which ketone I am going to get? Which ketone I am going to get? IUPAC name I want. I want IUPAC name. I have got ethyl magnesium bromide as the Grignard reagent and acyl chloride I have taken here is acetyl chloride. But2O, okay? But2O. All of you will agree with him? Arpit is telling but2O. Sanjana, she is telling methyl propanone. So we will see. So now we have CH3, CH2, then CO, then CH3. Right? Now, according to this, Arpit is correct. We can simply call it as but2O. But2O. That will be the more appropriate term. Sanjana, you got the point? Instead of methyl propanone, but2O, because this is the part of parental molecule. 1, 2, 3, 4. So ketones, always it will be part of parental molecule. Yes, that's where we have the but2O will be the product. If I have taken ethyl magnesium bromide, if I treat with the acetyl chloride, that's where we have the reaction in the presence of cadmium chloride. In the presence of cadmium chloride. That's how you should predict the products. That's how you should predict the product. Okay. Now, next one. Once again by using Grignard reagent only. Once again by using, yes, butane 2-one or but 2-one, accepted. Butanone, okay, accepted. But 2-one is accepted. Now that's where we have the reaction. Okay, fine. Archit, got the answer? So it should be butane 2-one. Fine. Even but 2-one you can write, no problem. Butane 2-one or but 2-one. Okay, fine. Okay. Done. So how we will come to the next part. Once again we are using Grignard reagent only. Once again we are using Grignard reagent only. Only thing here is another partner is different. That is from the nitriles. Preparation of ketones from the nitriles. Preparation of ketones by using nitriles. Hagadra, which is that another reagent? Once again Grignard reagent. So that's where we have the RCN plus RMgX. Okay. Now same as that of earlier case, there will be dipolarity. There will be dipolarity. What I mean to tell you is negative, positive, because nitrogen is electronegative. So negative, positive. So here also positive, negative, negative. Okay. So now that's where we have the positive part. It should go with the negative part. And negative part, it should go with the positive part. All of you will agree with that? So that's where we have the positive part, it will go with the negative part. And negative part, it will go with the positive part. So now there will be formation of an intermediate. So R, C, okay. C is attached with another R. So okay, I will make it as prime. So R prime and N. It is attached with the magnesium halide. N is attached with the magnesium halide. Now whatever I have written, it is correct. Whatever I have written, it is correct. Or anything I have to change. But my point. So positive part go with negative. Negative part is going with positive. Anything I have to change? Yeah, very good. There should be a double bond because carbon is showing 3 linkages. So there should be a double bond between carbon and nitrogen. So there should be a double bond between carbon and nitrogen. Only under that condition nitrogen will be also having 3 linkages. Okay, that's why we have the intermediate. It's not the final product. It is a intermediate. Now when it will go for acid hydrolysis, or you can simply mention as H3O plus. Now there will be formation of ketone. There will be formation of ketone. Any other product? Any other product? Grignard reagent. What will happen? Whenever it is exposed to the water, it will get hydrolyzed. Same logic. So there will be formation of magnesium hydroxy halides. Magnesium hydroxy halides. And another one will be ammonium. Ammonium. Another product will be ammonium. So that nitrogen will release as ammonium. Okay. So since we are talking about acidic condition. So that's where we have the preparation of ketones using nitrile group. Preparation of ketones using nitrile group. Any doubts up to here? Any doubts? So, nitrile group with the Grignard reagent, there will be formation of an intermediate which on acid hydrolysis will form ketones, magnesium hydroxy halides and ammonium. We are interested in this particular product, not other products. Okay? So this is where we have the preparation of ketones. Now another one method is that which we are going to discuss in tomorrow's class. Any doubts? Oh, Archit has already told, no doubts. Okay. Fine. This reaction, okay, important, not very important and all. Okay. So this reaction, important, that's all, not very important. Okay, na? So if you don't have any doubts, I will stop here and tomorrow we are going to continue. Fine? Thank you. Thank you very much. Take care.